Friends, welcome to my YouTube channel. Dhanesh here. Today I am going to discuss about ROC curve and the area under the ROC curve. In the last video, we discussed about sensitivity and specificity. Those two aspects we already covered. In the coming video, I am going to discuss about logistic regression. Linear regression we have already covered. We have covered many important portions in machine learning. We covered deep learning, convoluted neural networks, recurrent neural networks, LSTMs, GRUs, neural networks architecture, backpropagation algorithm, gradient descent algorithm. Many portions we covered. So today I am going to discuss about ROC, and in the next video logistic regression. Most probably tomorrow I will be covering logistic regression. Please subscribe my channel. Okay, let's start. We will start with ROC. See, ROC stands for, so what is ROC? Receiver operating characteristics. It's a graph and it stands for ROC, stands for receiver operating characteristics. This is ROC. See, our machine learning model is used for prediction. The performance of a machine learning model depends on how good is at prediction. When it comes to a classification problem, see, you are familiar with classification, especially binary classification. We can rely on ROC curve and the area under the ROC curve. So area under the ROC curve, you can write it as AUC. So AUC and ROC are very important when you consider the classification problems to predict the performance. So here this ROC is used to predict the performance of a classifier machine learning model, that is a binary classification. So how our classification algorithm, how our classification model it is performing, it is given by the area under the ROC curve. AUC stands for area under the curve. So it tells how much the model is capable of distinguishing between classes. Higher the value of AUC means area under the curve. If the value of AUC is higher, the performance is higher. AUC is almost near to 1, it is good, the performance is good. If the area under the curve is very less than 0.5, the performance is very low. That's what. So this is the initial introduction I can give you. Now I will get into the details of this ROC curve, how we can draw this ROC curve, and what are all the important aspects related to ROC curve. So ROC curve, as I told, it's a graph. See, graph means we have the x-axis and you have the y-axis. So what we will take along the x-axis and what we will take along the y-axis, that's really important. So ROC curve is plotted with TPR. TPR means true positive rate, and a TPR is on the y-axis and FPR. FPR is in the x-axis. FPR means false positive rate. So TPR is taken along the y-axis and false positive rate. See, TPR stands for true positive rate. FPR stands for false positive rate. So ROC curve is a graph between TPR and FPR. So what is this true positive rate and false positive rate. I will give more clarity on this. TPR, true positive rate, is also known as recall. True positive rate is also known as recall or sensitivity. So you can watch my previous video. In that video I have discussed about sensitivity. It is under the playlist supervised machine learning. You can watch that video. Please go through that. But I am explaining here as well, but you will get more clarity if you want to learn more. If you want to get into the details of sensitivity, you can watch that video. So true positive rate is it's also known as recall. It's also known as sensitivity. All these are same. And sensitivity or true positive rate is equal to true positive divided by true positive plus false negative. So for a binary classifier there are true positive, false positive, true negative, false negative. True negative and false negative, we will call it as type 1 error and type 2 errors. So a detailed explanation of true positive, false positive, true negative and false negative, they are known as type 1 and type 2 errors. It's given in the video in the same supervised machine learning playlist. There is a video type 1 and type 2 errors. You can watch that video. So in this video I am just covering the ROC curve. So true positive means the model predicted it as positive and it is true, that is true positive. True negative means the model predicted it as negative and it is true. False positive means the model predicted it is wrong. False positive and false negative are errors. It is type 1 and type 2 errors. So you understood, you can get a better understanding from type 1 and type 2 errors, the video that is in the supervised machine learning playlist. So this is TPR. Now I am going to discuss about FPR. So what is FPR? See, another term we discussed is, even there is a separate video for that as well, specificity and sensitivity. You can watch in the same playlist. So I am telling you, sensitivity I already discussed. Now I am getting into specificity. Specificity is equal to true negative divided by true negative plus false positive. This is known as specificity. But what is this false positive rate? See, false positive rate, FPR, is defined as 1 minus specificity. Very important. 1 minus specificity is known as FPR. 1 minus specificity means it should be, you can write it as, it is equal to 1 minus this one, specificity, that is Tn divided by Tn plus Fp. When you calculate this, you will get it as Fp divided by Tn plus Fp. This is known as the false positive rate. So this is the equation for the false positive rate. So you understood what is true positive rate. True positive rate is recall or sensitivity. False positive rate is 1 minus specificity. The equation also I derived. So you understood what we are going to discuss, what we are going to take along the x-axis and the y-axis. Now I will try to draw the graph of the ROC curve. ROC means receiver operating characteristics. Now I am getting into the performance analysis using AUC ROC. AUC means area under the curve. So now I am getting into the performance analysis. So if the area under the curve is near to 1, see, area you can calculate. If it is a regular shape, you can calculate length into breadth, or if it is a triangle, half into BH, or if it is an irregular shape, you can use a summation or integration. You will take small strips and you can integrate it. So different ways you can calculate the area under a graph. So if the area under the curve is near to 1, the performance of the model is excellent. So if the area under the curve is near to 0, model has worst performance. When the AUC, area under the curve, is 0.5, model has no discrimination capacity. This is the concept you need to understand. Now here, so see the graph we can plot. I will show you the graph. So here, this is your false positive rate. Here you have the true positive rate. You have false positive rate and true positive rate. See, your curve, when you plot between these two, let us assume that this is your curve. This is your ROC curve. Then the area under the curve should be under the graph. This is the area. So this is a irregular shape. So how you will find out the area? Mathematically, you will take a small strip. See, you can take a small strip here. This is a small rectangular strip. So first you will calculate the area. Here you can apply the length into breadth. Then you will apply the integral of this area. This we are taking it as, length L into, length is high, the breadth it is dx, L into dx. Then we will integrate for 0 to x, 0 to x, L dx. So like that you can integrate and find out the total area. This is the way you can integrate it. Fine. So what we understood is, if this area, when you calculate the area of this graph, under this graph, the shaded portion, this is the area under the graph. So this area, if it is the value you are getting, it is near to 1, then the performance of the model is excellent. If the AUC, area under the curve, is near to 0, the model has worst performance. When the AUC is 0.5, the model has no discrimination capacity. See, I will show you the different cases when you will get the area equal to 1 and when you will get the area as 0.5, and when you will get the area as 0.7 or different. How do you get all these things? See, I am going to show you that. See, let us assume that our case is like this. So you have true positive and true negative. This is true negative, and this is your true positive. So this is, the classification is excellent. It is, purely separated. When you plot this graph, you will get the curve like this. When you plot the graph like this, here you have taken the true positive rate. Here you have taken the false positive rate. When you plot this graph, you will get the graph like this. The graph I am plotting it, this green, like this. So when you calculate, this is 0 and this is 1, and here also it is, we have taken it as 1. Then the area under the graph, it is a rectangle, it is length into breadth. So length into breadth, it is 1 into 1, that is equal to 1. So in this ideal case, the area is 1. The performance is perfect. Now in the next case, see, let us assume that our model, it has come up with like this. So this is your case. You have this is true negative, and your true positive is like this. So some overlap is there. So this is the threshold. So the threshold is in between it. This is, we are taking it as 0.5. So this area, it is a false negative. this is false negative, this portion. This is a false positive. So there is an overlap. So the performance is good, but not ideal. In that case, if you draw the graph, you will be getting like this. It would be, the graph should be like this. Like this, your ROC curve. When you calculate the area under the graph, it will be, you will get it somewhere. You can use the process of integration. It will be somewhere around 0.7. That means it is 70%. The performance is around 70% accurate. See, when there is a complete overlap, in the next case I am explaining you, see, your model is like this. There is a complete overlap between the true negative and true positive. For example, it is like this. This is true negative and true positive is also like this. There is a complete overlap between true negative and true positive. Then your plot will be like this. It is, that's what I previously discussed. When you take TPR and FPR, false positive rate, the graph should be like this. Here, when you calculate the area under this, so this is 0, this is 1, this is also 1. So it would be, you can take it as, this is a triangle, this is a regular shape, so you can take it as half into base into height, 1 into 1. So it should be 0.5. So the accuracy is only 50%. So this, like this, you can buy. This is a very important concept in machine learning, especially for classification problems. Receiver operating characteristics. Here we are calculating the area under the curve, that is AUC, for the receiver operating characteristics, and finding out whether how much accurate the prediction is. So ROC curve, the AUC ROC curve, that means area under the curve, we are using to measure the performance of a classifying model or binary classifier. So for classification problems, the performance is given by the ROC curve. When this area under the curve is near to 1, the performance is good. If it is very much less than 1, the performance is not good. So that's what we understood from this. So that's all about ROC curve. So in the next video I will be covering logistic regression, and you see what I have to tell you is I will be coming up with more videos on machine learning, artificial intelligence, even machine learning, math and statistics. Please subscribe my channel. Thanks for watching.